if you have the debug privilege, the SE debug privilege, you can actually inject code into other people's processes. So SE debug is usually only granted to members of the administrator group. So if you are an administrator, I can not only inject to something like Internet Explorer, but I can inject into services.exe or an SVC host process or something that's a service that's running all the time on the system. Right? Okay. Other ways that you can inject code, app init DLLs. Every time a process starts, each DLL that's in this list will get loaded. Detours is a Microsoft research library. They created it back in 1999. It uses basically the techniques that I've described here, but it's wrapped up into a nice sort of slick package. Detours provides you with the ability to do all of these things, right? So I can hook functions in a running process. I can modify the import table of a process on disk. I can attach a DLL to an existing program file, so I can add a new DLL to an existing program. You can do all this actually just from the command line with the tools that they give you. So if I can call set DLL on the Internet Explorer file, and it'll actually modify Internet Explorer so that every time Internet Explorer starts, it loads my DLL in addition to all of the other DLLs that Internet Explorer normally would. So that seems kind of interesting. How the heck do they do that? Well, Detours doesn't, it's not a modification of the operating system. It doesn't require any special support from the OS. It was designed for sort of instrumenting programs after the fact, right, for doing performance tracing and on various pieces of Windows. So the way that it does this, the injecting of DLLs into files on disk is it actually creates a new section of the executable file named .detours. It goes between the export table and the debug symbol, so it's near the end of the file. The .detours section will contain the original PE header, so it's saved so that they can undo it later, right? So you can call set DLL to add a DLL to the file, and then you can call set DLL/R later to remove anything that you've added, and then it will just take the original PE header out of the .detours section and shove it back onto the beginning of the file where it's supposed to be. So if we look at what this looks like sort of in a PE file format, you'll notice that we have this .detour section that gets added to an executable. And you should never find standard Windows binaries in your C:\Windows System 32 directory with detours sections. If you do, you may have been infected by malware. And we've seen this in the real world in several different engagements where this was used as a method of persistence rather than adding something as a service. Well, they just detoured an existing Windows binary that gets called upon startup, and they added their backdoor DLL to that file. They didn't name their backdoor even listener.dll. It was named something. It was like some language. It was like English.nls. So it was you're like, oh, well, there's lots of NLS files on the system, and it blended in very well. Set DLL again. I can make Notepad start listening on the network, right? So not to belabor the point, but that's the kind of stuff that you can do. Okay, so when we perform DLL injection, and DLL injection, like I said, it's the simplest way of doing this because DLLs are sort of naturally position independent. When we perform DLL injection, load library requires that the DLL be on the disk or at least on an SMB share, right? So it could be across the network. But generally, right, so it's nice to be able to inject in somebody else's process and not have an evil process, right? But it's even better to be able to do that and not have a file on disk that could be found by an incident responder as well, right? So there's several ways to do that. The Metasploit project, so Metasploit has a thing called the Meterpreter that's part of Metasploit that uses a pretty clever method of getting around the way that load library usually works by hooking functions that are normally involved in reading the file from disk. And so the functions that they hook, you can see here, they hook nt map view of section, nt open file, nt create section, open section, and their hooks are real small and simple. All they do is they say, well, if the DLL being loaded is our Meterpreter DLL, then don't get it off of the disk. Just take it from this buffer in memory, right? So Meterpreter, as part of their shellcode payload, they push down the payload into memory, and now whenever load library is called for one of their DLLs, it just looks in memory and it lies to the OS about where that DLL is actually coming from, right? So they didn't have to write their whole own loader, which would be the other thing you could do, right? You could just replace load library with something that doesn't require things to be on disk. But it was much easier to simply hook these 5 functions, right, and work around it that way. Okay, so we can sort of demonstrate the way that Meterpreter works as well. Let me see here. So here I have Metasploit running. And I've got, so this is going to be my attacking virtual machine, and I have another XP box over here on the side that's my victim. So there's lots of, I'm not going to sort of spend too much time talking about Meterpreter, but it's, or rather about Metasploit itself, but very flexible, nice. They have all these exploits. So I'm going to use the set slice overflow exploit for Internet Explorer. And let's see. Man, that's slow. Perhaps I will just start it up again. It's almost as if something is eating all my CPU. That's all right. Okay, well, basically what's going to happen here is we're going to exploit the box that's our victim box that's on the right-hand side, right? And we're going to see a new DLL loading inside of that process, but there will be nothing on disk, right, that corresponds to it. So exploits, Internet Explorer. I don't know what is eating my CPU. There we go. Much better this time. Maybe I spoke too soon. There we go. Okay, so in the list of the huge list of payloads that Metasploit supports, you'll see that there are several of them tagged Meterpreter here. And one of them is just a simple bind the Meterpreter environment to a TCP port. Right here I'm just entering my IP address for this machine, so 10.37.129.5. Remember I said I'm exploiting a browser bug here, which has been sort of a very common theme of this year, I'd say, in my incident response work. People aren't exploiting network-facing servers anymore. They're exploiting clients via browser bugs and documents. Right? So that's certainly been something we've seen a lot. So here's a hostile URL, and if I was actually a bad guy here, right, I'd have to somehow convince this client to visit this URL, but that's not too hard of a challenge. If I run this thing, hopefully it's going to kind of appear to freeze Internet Explorer. If we switch back here, we'll see that I just got a new session opened. And if I move around my windows, I have a session. Here's the session that corresponds to that new machine. I can interact with the interpreter here. I can list processes that are running, right? So I've exploited the browser. There is no new hostile process running. Internet Explorer is just running my existing stuff. And let's see. So this will be sort of my first demo of the stuff that Jamie's going to talk about quite a bit, right? Using our intelligent response agent, I can collect information about stuff that's in memory right now for that Internet Explorer process. And I'll let that run, but I have one here saved. Let's see, on my desktop from a second ago. And if you're trying to find the evil here in Internet Explorer, there's some ways that you can do it. First of all, Meterpreter is not that sneaky in that it leaves stuff. It hides things on disk, right? So it doesn't put itself on disk. So if you're doing traditional disk forensics, where you come back to the machine and you shut it down and you make an image and you bring it back to your work, you're not going to find any signs of the fact that Metasploit was there. However, its DLL is actually in the list of currently loaded modules. It has a standard name, METSRV. And the way that we're going to find it here in our memory output is by searching for, I think this is right, execute, read, write. It actually created a couple of sections here in our binary that if I had collected the same data before Internet Explorer was exploited via Meterpreter, these two sections would not have been there, right? And so these are actually the sections that contain the injected code. And I'll let Jamie talk more later about sort of how we got this data that you're looking at in the first place and what kinds of things you might want to investigate, right? How you would continue your investigation given these two things. So I believe, switch back. I think I have one or two more slides. And then you're up. And I did something with the slide clicker. Okay, you can go to the next slide. Okay, so that's one example of the way that some malware does this, right? Another example is a RAT, right, or a remote access tool that we found at one of our customers on several machines called Poison Ivy. Poison Ivy is just one of many examples I've seen in the past year that use code injection. Next one. So here's what Poison Ivy presents to the hacker, right, to the intruder. Once they've created a connection to a machine, you get basically the ability to do all the things you would want to be able to do. Thanks, Jamie. You can see it's fairly feature-rich here. The client that provides all this data is actually only 10K in size, right? So it's a pretty impressive little client. It's packed, so it doesn't have obvious strings in it. All of the network traffic is encrypted. So, it's not the fanciest program in the world, but it works pretty well. And it uses code injection to hide its activity. And I'll just take you quickly through how it does it. What you're looking at here is the output from an API monitoring tool called Win API Override. And we're watching Poison Ivy 2 start up. Okay, so this is how Poison Ivy 2 starts. And you can see a couple of calls up here to process 32 next, process 32 next, process 32 next, right? It's looking for the Explorer process, right? So it's looking for explorer.exe. Each time it calls process 32 next, it next compares the string you can see right here to explorer.exe. Once it finds it, we see the exact sequence of functions I talked about earlier. So open process, virtual alloc ex, write process memory, virtual alloc ex, write process memory, create remote thread. Right, so it has now created a remote thread inside of Explorer, and its job is essentially done. Right, so Poison Ivy, the process, only needs to run for a second to inject its thread into a new process. All right, so that's fine. It injects itself into Explorer. Well, what's next? Okay, so now the code that's running inside of Explorer executes the following sequence of stuff. Process 32 next, compare the string to MSN Messenger, right? And I cut off the rest of it where it was looking for MSN Messenger. Once it finds MSN Messenger, open up that process.